Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No libraries, no engine, all our own code. Well, we're at a Friday where we finished the thing we were supposed to do yesterday. And so the next thing that we wanted to do, I kind of didn't want to start it just on a Friday when we're just ending. So we're kind of in a little bit of a snare here where I'm not sure what we should really start doing. We could try to look for the variable. I don't think that's going to pan out, especially not in just one session. So we got to figure out something else to do. Now, somebody on the pre-stream mentioned that they thought they might have seen a bug in the collision detector that was about a typo regarding what we were supposed to test against. I introduced a new variable instead of we were testing against it, and then I didn't type it in the right place or something. And so I feel like maybe since, again, we don't necessarily know exactly what we should be doing today, let's tackle that first and we'll see what emerges from it. Now, of course, it is day 88, so if you're following along at home and you pre-ordered the game, download day 87 source code. That's the stuff that I am working with today, and so you should be on that as well. Now, they were saying that it was a thing to do with test-p, so let's take a look at what test-p was doing and make sure that it actually does something reasonable with that. So I guess what I will say is the fact that we introduced test-p here and then never use it suggests that either there actually is a bug, as the person was suggesting, or we just got rid of the need to do it. But let's take a look here. So we're doing a test-p, we're doing a speculative collide of this entity and this other test entity, and then assuming that it actually occurs, we don't use test-p for anything in particular. So I'm not sure. Let's take a quick look and see. It's been a while since we looked at this code. Let's take a quick look and see what we were doing with speculative collision. So with speculative collide, it looks like for the most part, yeah, we're really doing more of a direct query here, which I assume we probably meant to let speculative collide take this test-p, right? I suspect that's what we were meaning to do and then just never did it. So I suspect we would want to actually have that work out. So get entity ground point is no longer actually a thing. We kind of said that the entity ground point is always actually there. So I'm not sure, we could pass test-p, but we'd need to have get entity ground point work through that test-p. So it's a little tricky. Well, so let's take a look. If we were going to pass test-p to this, to speculative collide, and say here is where we actually want to know, if you could actually do this, we pass in the test point. Then really what we want to do here is say that this mover ground point thing, we want that to be based off of test-p. Now, if we were still, like I said, to allow entities to return ground points however they wanted, what that essentially means is that get entity ground point would have to be able to take, for an entity p, it would then have to return the ground point if the entity were in that location, basically, right? And in this case, we pretty much know that that's always just going to return this directly. But it does seem like maybe we want to do it that way just so we can kind of, I don't know, allow that sort of thing to happen. We could also make it so that old code worked okay, like code that didn't want to know anything about that could just pass the entity p like so. So it could, do the same thing it used to be doing pretty trivially. Right? So this would allow us to do that call with a test-p. And yeah, we didn't really have a bug that was manifesting itself, so it's not like we can really test that. And again, we're kind of haven't finished really the collision detection stuff that we really need to do, and so at some level it's hard for us to know whether this thing is working or not. Yeah, it'd be kind of hard to know. We wouldn't necessarily see it either way. So we will need to put the stairwell back in probably first of all, so maybe we'll also do that. Yeah, of course we aren't really necessarily ready for that because we aren't doing the multiple ground level rendering stuff yet. But we'll see. We'll see how it goes. So let's see, add stair. I think the stairwell was the only thing that ever used that speculative collision so far. So yeah. All right, so let's put those stairs back in there and see how that goes. So, you know, if I'm coming up here, oh man. There's so many ground patches all over the place now. That's hilarious. And of course, there's more than fit in our cache, so like you can occasionally see them blinking in and out because now we've got 2 layers of them happening. That's pretty trippy. Yeah, so unfortunately, it's pretty hard to tell whether we'd actually fix that bug or not, right? Because we don't really have a clean way to have it manifest itself. So there's nothing we can really do about that for now, I guess. So yeah, what I should do is I should update our ground cache a little bit, just in preparation. I should say that we're going to have a slightly bigger ground cache. Let's take a look here. Where is that? Got our ground buffer count. So let's make that a little bigger. Let's make that 64 for now, so that we can handle both stairwells. So that, you know, because again, generation is super piggy right now. It's super slow doing that generation, and so we kind of want to make sure that everything, once it has been generated, it stays generated. Until we actually have some more efficient stuff happening there. But either way, it'd be nice to have a little bit more here. Yeah, so I think we're okay, at least, you know, if that bug was actually going to manifest itself, we would have seen it before now. So I think it's one of those things that we're kind of just fixing because you know, it should be busted. It just doesn't happen to show itself, so we can't really test to see whether we fixed it. But yeah. So, you know, one thing that we're probably going to have to do, and I guess maybe this is an indication, maybe we should do this today, do this a little provisionally. I don't know if it's a good idea or a bad idea, but, you know, everything's just kind of drawing in a random order now, so we can't even see sort orders and stuff like that. So maybe what we will have to do now is actually go in there and do a little preparation for next week where we're actually putting things into some sort of a render list, you know, so that we can sort them and do other stuff like that. Because we may be in a situation where we can't really do anything more logically. You know, we can't really do anything even just as test code without having it so that we can at least sort things in the renderer to some degree. We are getting, there's this texture seam down there, and I assume that that's just the 2 different levels being on top of each other. Yeah. You know, we've got another problem too that we're going to have to face. It's a lot of this stuff is just order dependencies, and I'm not sure exactly what we should do to break them. But like if we've got multiple levels of ground, one problem that we have is we don't have any way to scale bitmaps at the moment, right? And so without any way to really scale bitmaps, it's going to be hard for us to do anything in terms of you know, when things get smaller and we're on different height levels. So, you know, what we may have to do as well is do something like where we go back to pure orthographic just for a little while, so that when we draw things on top of each other, they're still the same size. We don't make them smaller when they recede. But I'm not sure. Again, this will be fixed once we have an actual render, but I just don't know the order to do those in. So, all right. So yeah, let's take a look at the to-do list briefly and see what's going on here. We've got our Z stuff, we've got collision detection, we've got multiple sim regions per frame, and debug code, asset streaming, audio, metagames. Yeah, I'm not sure. I'm really not sure what we should tackle. We need some little bite-sized thing we could do today that would be useful. And I don't actually know what that would be. Maybe starting to pull things out into a render list just is the best thing to do. I don't know. It seems like it certainly could be. It's plausible, right? So maybe we'll just do that. You know, maybe that's what we'll do. So let's start it. Let's do a handmade render group or something like this. Let's go ahead and just start shunting things out here because we've got a bunch of code that does rendering, and let's try to start unpacking it into something useful. That seems like the smartest thing, I guess. All right. So what we need to start doing in terms of rendering stuff is we need to start buffering things up somehow so that we can sort them, right? At the very least. Not to mention the fact that we have other things that we'd probably like to do during that buffering, like doing the translation of the coordinate systems, meters to pixels and y and all that stuff being flipped, and other things like that. We really don't want the game code thinking about those things. We want the game code to just work in world units all the time, as much as it can, and we want the renderer to just take care of stuff that has to do with rendering, so that if you change out the renderer or how it's being rendered or change the resolution or do all those sorts of things, we really don't want that to infect the game code, right? We want the game code to be able to work in some canonical set of units in a canonical way and have it just put out what it needs to be rendered, and then the renderer can take care of sort of all of that fussing, right? All the fussing that has to go on in there. And so if we take a look, we've already kind of got some of this, right? We've already got this sort of buffering that's going on here where we've got piece groups, right? So we've got entity visible piece group, and those piece groups get pushed, right? And you know they get built up, and then at the end, after the things all get pushed on there, there's sort of like an event that happens down here where they actually get rendered. And so what we could do instead of what we're doing now is just pull that piece group concept out and make that actually just record all the pieces, right? So that it just does all the pieces and then draws all the pieces. So we're kind of like almost there already, right? If we just kind of took it a little further. So maybe that's what we'll start with, okay? So I'm going to say that we're going to go ahead and just pull out one of these entity visible piece group things, right? So I'm going to pull that out here, and we're going to start fussing with that as, you know, as basically a render thing. So let's see, entity visible piece. Where is the piece group? There it is. This is just a part of the render push buffer. Hey, look, we have a to-do that says this is exactly what we should do. And you know what? I agree with that. So I'm going to go ahead and pull that out there. And I'm going to include this as we have included our other things. So I'm going to say, all right, we've got handmade.h. We've got handmade render. Oops. Handmade render group.h, and we've got handmade render group.cpp. So let's go ahead and compile this. I should actually make one of those. There we go. So all I'm going to do at first is try to expand that notion of the piece group there. I'm not even going to change the name yet. I'm literally just going to try to make it so that it doesn't get zeroed out. It just tracks everything, right? And in order to do that, we obviously have a problem, and that problem is the piece count here is going to be way too low for all the things that we actually need to render. Now, what I could do at first is I could just make it not be too low, right? I could just say, oh, it's giant. And so maybe that's what we'll do at first. And we'll see how that goes. So if I go ahead and take this, excuse me, if I go ahead and take this out of the loop and say, all right, we've got a piece group here, I will get that out of the transient arena, right? I'll just say, okay, let's get one of those. Oh, I call them mandalas in my main code base. Nobody uses that term, so I used arena on the screen. But okay, so what I actually want is this. So the transient arena. What I want to do here is I want to push one of these entity visible groups on there. So now we're actually getting it in sort of that inside this temporary memory region. So it'll automatically get flushed for us. We don't really have to do anything special there, right? And then I'm going to compile it. We're going to get that back as a pointer. So the piece group here now is actually going to be indirected. And that's actually kind of nice because it means we don't have to take the address of it everywhere, right? So that just works like this and so on. And then we're going to have to do one more thing, right, which is actually kind of going to be a little complicated, but it sets us up for what we need to do, so it's all good. And that is that the actual rendering now, if I were to move that outside, so let's say I move that out here, you can kind of see that we have this loop over all the entities, so we're pushing them all into the piece group. If I do this, Now, when I loop over all of those pieces, we have a problem, which is that, and you can actually just see from the compile error, you can actually see that when we, excuse me, what is that? Oh, sorry. There we go. Or maybe not from the compile error. Oh, okay, never mind. It would be nice if this were scoped inside here, to say the least, but unfortunately it isn't. I guess we could do that in a way that the compiler would probably be okay with. We'd do something like this, if that makes sense, where we're just going through and actually referencing it each time, but yeah, what are you going to do? All right. What I was trying to say is this right here, where we get an entity ground point in order to base off where all the pieces are supposed to go, that's a problem, right? Because now all the pieces are in one giant buffer. So we've taken all of the pieces that we want to render, we've put them in a giant buffer, and now we have no idea which one goes with which entity, right? So we need some way of knowing for a given piece what is its basis, like where was it supposed to be relative to, right? And so what I'm going to introduce on top of this for now, and I'm not totally sure this is exactly how we want to do it, but it's something similar. I'm going to introduce a basis here for our piece groups, right? So I'm just going to call this a render basis for now. And what this is this is going to be something off of which other people can reference their coordinate system, right? So, like we were saying here, we were saying we want that entity base P, and the reason that we didn't store that at the time was because we might actually move the entities around after we've built up their kind of render state, which, to be fair, isn't necessarily something that we want to do in the long run, so that may not actually persist, but if it does, we want to be able to do that adjustment after the fact. And so doing that adjustment after the fact here is just something that I'm going to allow for now in the renderer. And in order to do that, we need some method of indirection. And so what I want to do is I want to do something, excuse me, where our render bases can actually be set sort of after that fact. So let's see how we would do that here. So when we grab out an entity and we're going to actually do some rendering for it, assuming that I guess we actually know whether we push the bitmaps in here, right, where we're doing these push bitmaps, that sort of thing. What I want to do is I want to say, all right, give me a render basis, right? Give me some basis that these guys can be off of, and set this as the current default basis that everything that we render is going to be based off of. So maybe I'll do it like this, where we do like a push basis kind of call on the piece group, right? And then we can set that basis later. All these things will be relative to it, right? And then at the very end, we can do a pop basis. And maybe we don't, I don't know if we want push and pop. Maybe we'll just do a new basis or something like that. So I'm not exactly sure how we want to do that. We'll sort of fine tune that later. But anyway, that'll give us back that basis. And then after we do our entity movement, right? Then we can go in after the fact and set whatever that p-value was, directly off of what we would have done in the past, right? So like this. And so in order to get this out here, what we need to do is we need to see what the piece that we had pushed on, what its basis was, and just grab the point, that basis point off of there. So like this, right? And so all I'm really doing is deferring that setting till the end. So in order to make this work, like I said, each one of these guys, each one of these pieces has to know what basis it's relative to, right? And then we also need to know for these guys at any given time what the default basis actually is, right? So this way, when you push something on one of those piece groups, when you basically push piece groups on to the list of things to fill, each one of them, like when we do push bitmap, push rect, whatever, it calls the push piece function. What we can do in that push piece function, just say, oh, okay, anytime you push a piece on, we'll just say that whatever the basis that's currently set in the piece group as the default basis, that's the basis that'll actually be used, right, for the piece group. Essentially, that is what this coordinate will be relative to, right? This would also allow us to fix our shadow problem. there's a couple things we could do there too. But again, I'm just kind of doing this in sort of a very ad hoc fashion, just to sort of play around with it and start to compress it down into something more usable. I don't know that we'll want to do it this way in the past because there's some indirect, like we don't know what our performance situation is going to be and how much indirection is going to be a problem here. So I'm just literally porting the code as we had it, and then later we can decide whether we think that's a good idea or not, if that makes sense. So anyway, I've introduced that basis, and now when we actually initialize that piece group, you know, at the start of things, which is really, you know, now our kind of our renderer, we need to have a default basis, right? And the default basis can literally just be, you know, something that doesn't actually displace anything, right? So we can say that the default basis is just 0, 0, 0. It essentially doesn't actually change anything that's going on, right? And then we just point to that. So now everything by default is rendering there, but you know, in circumstances where we actually want to start changing it, we can, right? And so we could also do this way. In fact, we could do this way for now without actually having to add any actual functionality to the piece group itself, although we want to get there eventually. I can just say, all right, every time we want to make a new one of these, we just get one out of the temporary memory store. We go ahead and set the default basis for our piece group to be this one, so that everything that we push will be based on it, right? In fact, yeah, do it that way. And then at the end, we go ahead and set that basis P. We come back through here and we pick it back up again for each individual piece. And it's important to note that we never have a piece that doesn't have a basis because we start out with one that's the default one, right? We don't initialize this pointer to null. We initialize it to actually a valid basis. And that way we don't ever have to check to see whether a piece has a base. We just assume that it does, right? So this now should, in theory anyway, render all of our stuff in a second pass here, right? It should go ahead and actually give us exactly the same thing that we had before, at least in theory. Or maybe not. Actually, I just realized something we did not do. This actually does not get cleared here, which is not a good idea. So hold on one second while I actually do that, and then we can go back to what I was about to say. So default basis, game state, piece count is 0. There we go. And so that should, in theory, work. We push those bases on. We push everything relative to them. We set them to the correct thing. We then come through and draw everything. So let's find out. Let's see if that works. I don't know if it will or not. It appears to be the same as it was before, which is what we want, which is good. And so that's all, you know, that's all pretty reasonable. No worries there. And so now, if we wanted to, we could actually sort the things in there as well. We could sort the things by their z values and other stuff like that. So if we wanted to fix this like going behind trees problem like that, we could fix that. Now is not a good time to teach how to sort things, so we probably won't do that right now. But that is something we would do after, probably sometime soon. All right, so this allows us to see essentially what we're doing with the renderer. What I want to do is actually push everything through this now, like literally everything that there is, just to sort of get us even closer to having sort of something that looks more like a renderer, or at least the skeleton of a renderer where the renderer would go. So what I'm going to do is I'm going to grab, this to do actually goes down here. I'm going to grab this piece group and I'm going to move the piece group up and sort of give it some of its own memory effectively, so that it can operate and do all of the rendering for us. And I suppose actually for now, the temporary memory that we have here, begin temporary memory, I could actually enclose this for now in just in another one of those, right? So this is render memory. And these guys are overlapping, and so at the end, what I'm going to do here is I'm just going to end temporary memory for both of them, right? Like so. This is not what I actually want to do in the long run, but it's, you know, it's good enough for now. And so basically, I just moved the piece group up there. You can see that that doesn't really have any effect yet. Things are still working exactly the same way as they were before. But now what I can do is start to change all of the draw calls that we were doing before. I want to change them all into draw calls that operate off of this piece group, right? That's what I'd like to do. And so let's go ahead and just do that slowly. So we've got push rect, right? And push rect is a thing that allows us to draw rectangles using the piece group stuff. And so, you know, let's just translate this stuff, I guess, somewhat directly into the piece group. Although, you know what, maybe this first one, I'm not actually certain that I mean what I just said, because let's actually save that one, since that's actually kind of a special call. This is a clear, right? And I think we might want to add that as a real call. All right, so first let's do this bitmap calls here. These are the ground buffers. So in order to do this, if we were going to draw all the ground buffers, if we turn this to a push bitmap call, then really, let's see, what I have to do is pass an offset, which we don't need. Oh, I guess this actually is the offset. Sorry, it's ground x, ground y would be our offset. In fact, I guess I don't need to pass it as an xy. I can just pass it like so, as it actually already is a vector, right? And then alignment, this push bitmap call, this was aligned off of just off of its own center, right? It's this right here. So really, we could pass this in as if it was the alignment. I don't know if we actually want to do that or not. We could just say there's no alignment for now, although more correctly might be to pass it in as the alignment. And I think that's all we really need to do for pushing the bitmaps on for the ground buffers, right? Or not. That is not what we wanted to see. All right, I take it back. I take it back entirely. That is clearly not the right place that we're actually trying to draw these from. Oh, well, you know what I just realized? This is still doing all of the translation, like the X, the Y. This is still doing all of that sort of inversion, scaling meters to pixels, doing all that stuff. And we don't actually need that to happen anymore, because that's actually happening, in the actual, quote-unquote renderer now. So let's take a look in there at how that's working. So push, I'm going to copy these guys out so I can see them, so I can more readily kind of look at them, right? I'm going to take these guys and I'm just going to put them in here so I can see them. Let's take a look at that. Okay. So, all right, if I look at these guys here, it looks like essentially we do some translation. So we do translation of the Y. We flip the Y here. Alignment is actually not in world units. It's in bitmap units. So this is a bunch of stuff that we really want to clean up. So let's take it one step at a time. But that's really, I think that's maybe what I want to start doing there, because that's really, it's going to be impossible to get this stuff right. It's so janky basically that we kind of want to start thinking about how to regularize all of these sort of ad hoc rendery things, push them down into something clean, so that we can kind of get rid of all that craziness. But yeah, so if we take a look at this, we don't need to do meters per pixel to pixels anymore. The delta just is the delta. We don't have to invert y anymore, so that's still just going to be straight, right? The alignment that's in pixels, we want that to be half the width, half the height, right? And so let's go ahead and put that actually into the alignment field, because we want that to be, again, done in pixels, not in pixel space, not in meters. In meter space. Right, so there we go. Let's get that out there. And we don't need to adjust for the screen center anymore, because that's taken care of for us as well. So really delta x, delta y is just where the ground is, which means essentially it's just that, right? So let's take a look at that and see where we're at there. What is the complaint? The complaint is those are integers. That's true. Let's see. Cannot convert argument 3 from V. Okay, it just wants the XY there, huh? Where was the Z? So push bitmap. Where does the Z go? Offset Z. So for some reason we lost our offset Z here, but it would be that, right? Like so. Cover 6 from V2 to real. Yeah, okay, so that's that. All right, sorry about that. That was a little janky there. All right, well, we're not quite there yet, because we're now drawing our tiles in the wrong places, unfortunately, because you can see that our seams have come back, right? Although, actually, you know what? That may just be the draw order, because now we're drawing 2 sets, and one of those sets is potentially Z shrunk. So let me go ahead and do our turn off our stairwell again, since we're not really ready for that yet. All right. So, okay, now we're back to something we know is actually there. So let's see. So that, we have introduced something that's not drawing these in the place that we actually want them to be drawn. So why is that? What have we done incorrectly here? Delta Z, let me just double check that delta Z is not causing us problems as well, since we don't really have I'm assuming it's not, yeah, because delta Z should be 0 in these cases. All right, so let's figure out what we've done wrong here in terms of rendering. Let me make sure again that we are actually doing something sane with the with the Y values and so on. So let's take a look. We're properly doing our meters to pixels here, and we're negating that Y offset, which is what we want. Now we should take a look at what's going on in the draw code, because I guess I don't technically know what we're doing here anymore, since I don't actually remember. So yeah, the basis P is not actually being used at all, because that'll just be zeros, right? So that's not going to affect it. The screen center X and screen center Y is what we were using before. We've already negated the offset Y, right? That already happened. And we've got that alignment that should be correct, because we did that as half the width and height, which is what we want. The entity Z is still going to be 0, so that's good. So that won't affect it either. And the Z fudge only multiplies values that were already 0, right? So this should really just only amount to screen center X plus the delta X, which is what we wanted. I guess entity this piece, entity ZC times entity Z. Of course, entity Z is 0, so that term will also be not there. So it looks, at least somewhat to me, that looks like that should be coming out to the same values. And I'm not sure why it isn't. That looks like that should have been the same values as what we were passing to it originally, right? And so let's take a look and see if there's something I did that was more subtle that makes some sense as to why it wasn't working. So with the delta subtraction, we're grabbing that out, right? We've got the alignment is half the width and the height because we want to move it backwards. Well, I'm assuming, yeah, that's the alignment point, so that doesn't need to be negative because we already negated there. Yeah, so that's a little unusual. So what that looks to me like it should have been correct. And I'm not entirely certain why it wasn't. What I'd like to do is be able to step through this and look at it a little more carefully. In order to do that, I feel like I'd have to cut down on the number of things going through this list so I can see them. Although, you know what? The ground buffers are going to be like the first thing in the list anyway, so that does help. But I'll take one more look at it to see if I can find anything, but then otherwise I guess we're going to have to kind of dig in a little bit and see what's going on. Yeah. Because otherwise that looks fine to me. That looks like it should compute the same value, right? Because screen ground point X, entity ground point X and Y are going to be screen center X, screen center Y, right? Like here and here. And then the piece offset X and Y, the piece offset Y has already been negated, right, to go in the opposite direction. So that's already correct. And then we should end up passing the exact same stuff to draw a bitmap that we were passing before, right? And so there shouldn't be that kind of weirdness happening there. And I'm not sure why there is. Because before we were just doing a draw bitmap of exactly that, with the displacement Yeah, off from the center of the screen. So that's really odd. That is really odd to me. And I'm gonna see if there's something that I can easily... You know what? It's drawing the same bitmap everywhere. Why is that? I feel like I've introduced a bug where we're always drawing the same bitmap. What? Oh, snap. So that, you see what happened there? I don't know if you saw what happened there. I'll give you guys a little bit if you haven't already got it yet. Maybe you had it before me, right? So in order to conserve on memory, right, we were just, we weren't actually sending the whole loaded bitmap down. We were just using one on the stack, right? And so what we wanted to do, this is kind of funny. So what we wanted to do is we wanted to defer that rendering, and we were not saving the actual loaded bitmap itself. We were instead doing a pointer to it. But doing a pointer to it means that this trick doesn't work anymore, right? This trick doesn't work anymore because we don't actually have a bitmap to point to. It's just the same stack bitmap all the time that we were reusing. So that, yeah, that's not very helpful. I wonder what we want to do to solve that. We could push whole bitmaps on every time we render. That seems wasteful. So I wonder if maybe the smarter thing to do is just say, all right, well, you know, the number of ground buffers is relatively low. So maybe it just was not, it didn't make any sense for us to store that every time. I'm not sure. The other thing we can do is use kind of a dual, we could do something where we, when we do render pushes, we basically have two pieces of information that go with it. One is the size of the thing, and one is, is actually the sort of the pointer to the bits. But I think I'll just go ahead. I mean, it was a silly thing to do anyway. I think we'll go ahead and say, let's just put that back to being a whole bitmap. You know, why not? All right. So if we do that, let's do that. If we do that, then now we don't have to do this anymore, right? We don't have to do the ground bitmap template thing. So I'll go ahead and pull that out. We don't have to do that, right? And so our ground buffers, we can now actually just get the buffer that's actually off of ground buffer itself, like that. Bitmap, like so. And got to take the address of it. Let's see here. And these are now arrows. So buffer is now changing. This is one of those things that it's so lame in C that you have to keep flipping between two things. It shouldn't matter which one it is. It's always lame that you have to deal with that. Anyway, ground bitmap template is not a thing. You're very correct that it is not a thing. So all we need to do here is just change this to actually be the thing that we wanted to use in the first place. Like so that'll save the bitmap. And similarly here, we can just go ahead and call that out. Say, all right, get the ground buffer bitmap. Anyway, get rid of that sort of caching there entirely. Okay, that was pretty funny. So we actually were drawing it just fine, I think. It was just a case of we can't defer rendering on that particular thing because we didn't have anywhere to say where the bitmap itself actually was. All right, so let's see if that fixes our problem. And it does, so that's good. So now everything is going through the deferred path. We're building up, well, not quite everything. I guess we still have a few more things potentially to get rid of. Let's take a look here. Oh, no, I guess we did. So really the only thing, the only thing that we're calling, the only place we're calling it is there. So we've got draw rectangle calls. Those are actually still occurring, right? But we don't have any more draw bitmap calls. So all the draw bitmap calls are going through the same path. So that's pretty cool. Yeah. All right. So what I would like to do here, I don't know why we're still doing this. This was some old test code that we were trying to draw some, I don't even know what we were trying to draw. I don't even remember what it was from, but these are not actually things we actually needed. Let's get rid of those. So what we would like to do now is we'd like to actually get rid of that other draw rectangle call, this one right here. And what this was this was just a clear, right? And so what I want to do is I want to, I kind of want to get that in as its own call, if that makes sense. And the reason that I want to do that is because not only do we want that to be its own call, probably like clearing the buffer should be something the renderer knows about, but that'll actually be our excuse to now kind of turn this into more of an actual quote-unquote rendering system, or at least the skeleton of one. All right, so what I want to do, first of all, let's stop calling this entity visible piece group, because that doesn't actually make any sense. Let's call this a render group, right? And now what I want to do is change entity visible piece group to be render group, like so. And this is literally just search and replace, right? All I'm going to do is just straight up search and replace. So let's see here. All right. So search and replace, a lot of fun for the whole family. We have search and replace. We now have a render group. And this is actually, for now, I think what I'm going to... I'm not sure exactly how I want to do this. It's hard to say. I'm thinking it through. But what I would like to do is I would like to extend this notion so that you can have multiple things pushed onto this render stack. And I don't know whether I want them to be fixed size or not. The thing is to know how far to skip to the next one. All right. Here's what we're going to do. I'm just going to do it this way for now, and we'll see whether we like it or not. All right. So what I'm going to do is I'm going to say that the render group no longer has this kind of weird thing where it's just got some number of pieces or whatever it is there, right? I'm going to say that I'm going to actually do this as a linked list, I think. I'm really torn with how I want to do it. I really just don't know. I don't really want it to be a linked list. I kind of want it to be a packed set. All right, no, I changed my mind again. I'm wildly in my head. There's all these like voices saying which one that maybe we should start with, and when that happens, it's best to just pick one and go, and then you see where you end up, because that usually means that there's no perfect decision. But anyway, here's what I'm actually going to do. I'm going to say that we've got some memory, right? And that memory is the push buffer, right? And the phrase push buffer is usually used in rendering to refer to a buffer that you just push things on, right? And so what we're going to do is you've already kind of seen it happening, right? We've just organically created it, which is we were kind of putting these visible pieces, these entity visible pieces, we're kind of putting them onto this buffer, and then we're drawing them all, right? And then when we're done drawing them all, we just throw the whole thing away. It's just gone, right? Goodbye. And so what I'd like to do is extend that notion to say, okay, we've got a push buffer. That push buffer is now just going to be some chunk of memory. And we use up that chunk of memory, and then we would go back and retire it in order, or we do other fancy things. Who knows, right? But I'm just going to extend that concept to say, okay, we don't have that. We actually have some kind of arbitrary memory in there. And when you do a push piece call, you actually push a certain size onto that push buffer. So I'm going to do something like push buffer size here, like how big it is. And I'm going to do another thing here, which is like max push buffer size, right? And then I'm going to actually introduce, I know you've only seen this once or twice from me. It's scary. I'm actually going to do something that actually just creates one of these, like allocate render group, right? You've seen me do this maybe once or twice before. I know it's rare, but you're going to do allocate render group, and that's going to pass in whatever that max push buffer size is, right? And what this is responsible for doing is this is basically responsible for getting us one of these buffers that we're going to work with, right? And so obviously that's going to need to be able to get it from somewhere. And the place that that's going to get it from is going to be one of our memory arenas, right? So that's going to take a memory arena to get it from. And what's going to happen here is it's going to push space for itself onto the arena. And then it's also going to push space for the push buffer, right? So it's going to do a push size after that. And the push size call is, well, you know what, too? Do we actually even have a push size call? We don't really. We don't really have one. Let me see here. Push size start at CPP. So that's the only place that actually gets used. So I'm going to change that to that. Okay. Okay. So we've got a push size call now. In theory, I'll implement one. It's not really implementing a push size, so I'll just type it in right now. Really, all I'm talking about is making this a macro, right? And the reason I'm making this a macro is for debugging reasons that we'll see later. I'd like things that work with the allocator. I would like them all to go through a macro. I don't want anything that calls the allocator going directly through a function call, so I just wanted to nip that in the bud. All right, so we want the max push buffer size to get allocated here, and I want to store that in that push buffer base pointer, like so. And yeah, that's basically it. I'm going to initialize all of the fields of this render group, and I'm going to do it exactly the way that we were doing it. Again, this is really just, again, more of that sort of compression-oriented approach that you know I like to take. I'm going to essentially pull out what we were already doing, this whole stuff here. I'm just going to do that in here, and I'm going to call this render group thing, like so. I'm going to call allocate render group right here. That's going to come out of the transient arena. And I don't know how big our push buffer is going to be. I'm going to say that our push buffer is going to be 4 megabytes. I have no rhyme or reason for that at all. Totally random. To do, Casey, decide what our push buffer size is, right? So yeah, so when we go in here, now we're actually doing initialization in a little bit slightly more formal fashion. I want the default basis. I would like that default basis to actually get allocated as well, right? So I'm going to push that on here, push that render basis struct, right? And then I'm going to initialize it, like so, right? We've got the game state, so we're going to need that to be passed in here. Although, to be honest with you, I don't know why it even needs the game state. I don't remember. So I'm assuming that game state was used in here. Oh, it's for meters to pixels. Is that true? Is there any other use for it? No, it's just meters to pixels. So I'm not going to store the game state. Instead, what I'm going to store is meters to pixels for now. And that's because I would like to get this into a state where it's clearer sort of where these like translations and stuff are happening. So that's what I'd like to do so that we're not accessing the game state. And so meters to pixels is actually going to be in here. Temporarily, that's probably going to go away in a little bit as well. All right. So we allocate that. We need to initialize default basis, piece count. We did that. So now let's initialize these guys. The push buffer size is 0 right now. The max push buffer size is whatever we were told that it was. And now we have our renderer, right? Piece count is actually result. Okay. So now we've got a problem, and that is that when we do push piece, we can't actually get one because we don't have that pieces array anymore. Of course, what I should do also is kind of take a look at some of these other, see what we're getting here. Push size, did I mess up the macro for push size? Push size, yes I did. There we go. Okay. Ignore that error for now. Push size, oops, and one more bug. That's supposed to be an underscore. Okay. So let's see where we're at. Push struct, piece group, undeclared. I don't know why I thought I replaced those, but evidently I didn't. Piece count. There we go. All right. Default basis goes push struct render basis. That needs to come off the arena. Allocate render group function doesn't take 2 parameters. You are correct. It takes game state meters to pixels now. let's see here. Render group. Pieces. Yes, I know that. Piece group undeclared identifier. Okay, and now we just have to change piece group to render group. And we should be in pretty good shape. Yeah. Yeah. All right. So we're in pretty good shape. We just need to do a little more work here to get our push buffer situation straightened out. And so what I'm going to do here is I'm going to go ahead and say in push piece, what we're going to do is instead of using any of this stuff, what we're going to do is say, all right, assert that however big this push piece is actually potentially going to be one of many things we push on there. So I'm actually going to do is do a push size onto buffer, or a push. I don't know what we're going to call this. Push onto push buffer or push render. I don't know. Push render elements. I'm not sure. Don't know what that's going to be called. Point being, we've got a thing that is going to take our render group and a size, some size, and it's going to push that size onto our render group, right? So what it's going to do is it's going to say, all right, let's see, we're going to have a result here, right? Let's see if the group can fit this thing on it. So if the max push buffer size plus our size, right? If that is less than, I'm sorry, if the current push buffer size plus our size, if that is less than the max push buffer size, then we can fit the thing that we want to push onto our push buffer, right? So that's all good. And so if that's true, then we can go ahead and take whatever part of the memory is at that location, so push buffer base, right, plus that push buffer size. We can go ahead and take that and make that be what the result is. That's the actual place that we can write to in our push buffer, right? And then I realize I'm going through this kind of quickly because I wanted to kind of finish it up. So in the Q&A, I'll kind of go over it a little bit more so that everyone knows what I'm talking about here. But anyway, so then we're going to just increment that push buffer size by whatever the size is, right? If we couldn't get it, I don't know if we have invalid code path. We do. Awesome. If we couldn't get it, we're going to mark it as invalid code path. Now, it's not actually going to cause a crash or anything, but it is going to be something that we know we've overflowed the push buffer. We've done too much rendering and we can't store any more render commands, right? So we want to make that be an alert that would tell the programmer something's gone wrong. So that's our push render element. And so if we want to get a piece here like this, what we can do is say, push render element instead of doing this. And then we can just say, oh, okay, we want to take the size of entity visible piece, and I want to push it onto this group. That will get us one back, right? And that should just totally work. No oddness going on there. Everyone's happy. Everything's good. And so the only thing we have to do now is we just have to figure out a way to actually walk those pieces. And since we're running out of time, let's kind of just stub that out for now. Let's just say, all right, we're going to grab the render group push buffer base. We're going to cast that, to a piece like so. And what we're going to do instead is we're going to say like a base address, right? Our base address is 0. While the base address is less than the push buffer size, we are going to continue processing. And so what we're going to do here is just say, all right, grab out whatever the push buffer base plus the base address is. That's going to be the next piece. And then for now, we'll just say increment it by the size of an entity visible piece, right? So let's do that. Hopefully that'll work. It does, and off we go. So we just got to the point where it's the Q&A. So I will probably actually start the Q&A here. Let's do that. But what I'm going to do before I start looking at the actual questions is just quickly go over what I did because I slammed it in there pretty fast. So let's take a little bit on the whiteboard, on the blackboard, to just explain what I did there. Just kind of refresh things. I was a little manic today. I admit that. It was a manic day. Things kind of went manic. All right, so here's what happened. If you recall, we had a thing called a piece group, right? And a piece group was something that we had sort of invented. Invented is a strong term. We had introduced a piece group because what was happening was we wanted to draw characters, right, that were multiple pieces, right? We had the hero. He's got a cape. He has a head. He has a torso, right? He has a shadow. These were 4 separate pieces, and they were all based on the same point. There's a point, and each one of these was like offset from the point in some way, right? But we didn't know where the point was until after we'd already done after we'd already executed the code that wanted to assemble this. So what we did is we introduced this concept of a piece group, which just recorded those things. So what it would do is it would say, oh, okay, I've got a head, I've got a cape, I've got a torso, I've got a shadow, and it would record these offsets. So it would say, oh, the head is this offset from the point that I don't know yet, but at some point. The cape is over here, the torso is over here, the shadow's over here, right? Then, after we were done, and we knew what this point was, we'd feed this point into this list and basically say, okay, using this point, walk through the bitmaps that you recorded and draw them using that basis point. Okay, that's what we had at the start of today. What I decided to do was turn this into a render group, which basically sets us up for our renderer. So all I did was say, let's do the exact same thing, but instead, and I did this in steps, as you could see, so I didn't do it too big at one time, and that just, again, that's compression-oriented programming, just trying to do things in a way that slowly moves them towards the right solution so that you can constantly see whether all your decisions are right and all of your pieces are working together properly. Because it's always the interconnectivity and the interrelationship between things that makes programming hard. It's not any individual piece of code. Individual pieces of code are different. They could be algorithmically hard, but it's a separate thing. It's not how code gets messy, right? So anyway, so what I wanted to do here was say, let's turn it into something where instead we've got a render group, which is basically a buffer, right? That's just some memory. So it's just some memory we're going to set aside. And then what we're going to do is we're going to write things into this memory that tell us what to render. Right? And so we did exactly the same thing as here. So the head gets written in here, the cape gets written in here, the torso gets written in here, and so on. Right? And so we're doing that already. We've already got that set up. But what we haven't done yet is made it so that this can be heterogeneous. Right? Right now these are just piece, they're those visible piece things. Right? Just like they were back here. But what we're going to do, maybe we'll start this on Monday, is we're going to turn this into a heterogeneous push buffer, which means that things in here can be all sorts of different stuff. So maybe one of them says to draw a bitmap, another one says to draw a rectangle, and we were supporting that in this one as well. Another one says to clear the screen, another one says to do, whatever, right? And so this will basically become this render group will be a group of commands that the renderer is supposed to issue in order to draw something. And again, unlike before, we were just doing it for one character at a time, now we're just doing everything in there. And we'll figure out a way to bake our sorting into this as well, but we haven't really thought about that yet. So that's all I really did today. It was just a bunch of code sort of massaging, really, but that's it. So let's see if we got any questions. Questions. If you'd like to ask a question, please prefix it with Q:, so I can see it. And also, please keep it to stuff that we've done in today's stream or a previous stream. If you want to ask off-topic questions, we do that typically before the stream starts. So if you want to come back Monday, 15 minutes before starting time, we're usually here just hanging out, chatting. Anyone? Anyone? Is this going to be a 0 question stream? Will things like filters end up in the render group? Yeah, probably. Basically, anything that we're going to do will probably end up being represented in the render group. Because I didn't have a drink today. I don't know what I was thinking. I started making tea and then I forgot to pour it. The render group will basically be the thing that we hand to the actual renderer and say, go. And so for the most part, everything will have to be in there that's parameterizable. So, you know, maybe filters won't be in there because filters might not be parameterized. Maybe they're applied the same way all the time. But assuming that the filters like turn on and off and have different rates and stuff, the render group will probably want to encapsulate most of that stuff that we want to do filter-wise in a parametric way. Will have to go in there because it'll get handed to OpenGL if OpenGL is supposed to render it. It'll get handed to our software renderer if our software renderer is supposed to render it. It'll get handed to Mantle or whatever we implement a renderer for. You know, the render group's got to keep that stuff encapsulated. And that's the only way we're really going to be able to have switchable renderers, right? Which I'd like us to be able to do. And so pretty much everything, including filters, is probably going to have to go in there. But again, if it's something that literally doesn't need to be specified at runtime, it's just kind of known, then we wouldn't need to put it in there. How long will the renderer take? I have no idea. I really don't know. I mean, part of it depends on what we decide our goal is. There's two ways we could look at it, right? One way is that we're strictly doing the renderer as an educational experience, and we literally don't care how fast it is. So we're just trying to write a full renderer that does exactly the right things in the way that is most educational to do them. But then we always ever just run with hardware acceleration, right? That's one way we could go. Another way we could go is we actually want the game to actually run on software rendering in a way that you could play it. So it's got to be fast enough for that. And I don't know which is the right answer of those, right? I suspect what we'll probably do is we'll probably take a cautious approach to optimization and say, let's write the renderer as if it were a graphics card. And so it's basically a simulation of a graphics card. And we will try to make it run reasonably fast. So we'll show how to do code optimization in there, but we won't try to do algorithmic optimizations that are totally different from what a GPU would do, because that ceases to be very interesting in an educational sense, potentially. So I don't know. So I'm not sure exactly how we'll take it, but depending on how far we want to push optimization, I would say, is what could sort of control the length of time that the renderer takes up. Can you give us examples of what some of the simpler things will be in the render group? Yeah, clear. So that was the one that I would have hoped I would have time to get to. I didn't quite. Clear will be a command in there, like clear the buffer, right? Are there any static code analysis tools for C Visual Studio that would help pick up bugs like unused variables, etc.? You know, I don't know. I know there are good ones for Clang. So if you're compiling on Linux, there's a bunch of built-in things in Clang that do both static and dynamic analysis tools, I think. There's like address sanitizers and stuff like that. I don't know if Visual Studio has them or not. I mean, obviously there's thousands of aftermarket things for Visual Studio that do, but whether it's got them built in, I don't know. I never use them, so I have no idea. But you'd think they would by now. If they don't, you know, one option is it's usually good to maintain like a Linux or a Mac port anyway, and Clang does have them, and you can turn them on. And so that's another option, is just make that an excuse to port your code to Linux or whatever. Get your thing running on Linux, you can run it. If you do like we're doing, where the platform code is completely isolated, you don't even have to port to Linux and actually get it running to run address sanitization. You can run the game in a loop, just not throwing away the output, right? And using address sanitization and static analysis tools to find stuff for you, right? And so that's a pretty cheap way to do it, and you don't have to buy an aftermarket thing for Visual Studio. But it may be that Visual Studio 2013 or something has those already, so I would do some searching online, because it may be that they have. I just don't know because I don't use them. So are you planning on abstracting away the renderer as a layer, similar to how we separated the platform from the game code, so that the various renderers will be operating on the same data structures? Yes, essentially. I'm not sure I necessarily understand what you mean by operating on the same data structures, but basically, yeah. We will have a render, when we're done with this, we'll have a render group spec, basically, that's like, this is the format for a chunk of memory that means draw this stuff in this way. And anyone who wants to implement a renderer for that can do it, right? And so it then becomes free to just plug more renderers in. Well, free. You have to write the renderer, but it becomes, it doesn't require us doing any work inside Handmade Hero to support alternative renderers. So if you want, you know, and people could go nuts with that. If someone wants to do like a D3D port and a mantle port and a whatever port, whatever, and we don't do those on the stream because we pick some other things to use or whatever, it should be very easy for people in the community to go ahead and say, oh, I wanted to make a renderer for such and such, so I did, right? If you were going to write an algorithm to generate Sudoku puzzles, how would it work? I'm sorry, that's more of a pre-stream question. That really doesn't have anything to do with what we've been working on. Unused variables are a warning on my compiler. Did you turn that warning off? I use an allow local macro when I want it to ignore the variable. I did turn that off. However, I'm not sure, but I think what GPL White was asking for when he says, are there any static analysis tools that would help pick up bugs like unused variables? I assume because he said static analysis tools, he wasn't talking about the trivial ones that the compiler catches. I assume he was talking about more complicated ones that, you know, aren't easy, like that involve function calls or something that like Visual Studio or Clang won't by default catch for you. I assume that's what he was talking about, but I don't know. If he's only talking about getting Visual Studio to just say, hey, this was an unused variable, then yeah, all you have to do for that is just turn that warning on. Would it make sense for the render group to contain render groups itself? Sorry, Friday means fried brains here. Yeah, I mean, I can't say for sure that that's what we'll do, but that is totally something we might do actually in the course of what we're working on. I don't know, because I probably would say that we'll end up with the render group kind of being a bit of a tree-like thing inside itself anyway, so I don't actually know whether that'll actually be necessary, but it's a totally reasonable thing. G7 Samurai, I meant whether you plan for the data describing what needs to be rendered to be in a format such that it's suitable for both software and hardware rendering. Yes. The only thing we won't do is try to get maximum hardware throughput because we're a 2D game, so we don't need it. It's like hardware throughput is so astronomically higher than what we have. We don't have to really worry too much about that. So, you know, you would build your push buffers in the hardware format if you wanted to be absolutely the fastest you could possibly be. And we have this intermediate buffer format, which introduces some overhead in terms of processing time. So the only thing we won't do is eliminate that processing time. And the reason is because it won't affect our frame rate at all. But if you really were trying to like get down to it, that would be something you would want that would be different for hardware than in software. But yeah, so for other than that, we will be doing it so that it's basically friendly for both. Will our hero always be taller than the treetops? No, he's giant right now, just because. Eventually, he will be probably a little shorter than the trees, but not as much shorter as he would be in real life. It is not quite to scale in terms of how the art will look in the final game. The art will be you know, it's interpretive. It's an interpretation. So think people are not the same size relative to trees that they possibly should be. Let's see, any more questions? Any more questions? Are there any more? I do not see any more programming questions, but maybe I'm just missing them. Maybe I am just missing them. All right, well, I guess that is that. I guess we've finished early. Okay, so let's go ahead and let's see. Let's close this down, close that down, clear that out, and back to square one. All right, double check here. Are we keeping the 5 p.m. schedule? Well, I guess we've got a little bit extra time here. I don't know. What do people think about the 5 p.m. schedule? I guess it's a little bit weird to ask here because the people who are here are people who made the 5 p.m. schedule. But yes, I think I would like to keep the 5 p.m. schedule. I also feel like, I know this is a little paradoxical, but I feel like on the 5 p.m. schedule, we haven't been getting as much noise in the chat, which I feel like might actually be better. I know it's like maybe not as good for if you're trying to make the series as popular as possible, but at the end of the day, I feel like kind of having a more sensible chat is valuable for people, and I am not a Web 2.0 maximizing consumer acquisition rates kind of a guy, and so if it turns out that this is a friendlier time in terms of keeping the chat sane, less work for the moderators, and stuff like that, I kind of feel like maybe that's a good thing, you know. But that could just be that could just be that this week happened to be calm and easier, so I don't know. So yeah. So we'll see. I'll try to post this weekend on the forums a question to see if people are having trouble with the 5 p.m. slot. But I think we'll try it for another week. I like it. I think it's good. So yeah. All right. Well, let's wrap it up then. I think it's a reasonable time to wrap it up. Thank you everyone for joining me for another episode of Handmade Hero. We started the renderer push pepper stuff today. I wasn't anticipating doing that, but it just happened. And so I think what that kind of means for us is, again, stuff may go crazy. Stuff may go crazy. Maybe next week we'll be doing renderer stuff. I don't know. Like I said, we made a to-do list. It wasn't meant to be in order. So I reserve the right to pick out the stuff. If we have momentum on something that we're working on, then I say we go with it. I don't like having any kind of procrustean bed that we've got to sleep in every night. So yeah, we'll see. I thought we were going to do ground level Z stuff tomorrow. Maybe we'll on Monday and starting next week, but maybe we'll actually go through and do some renderer stuff and get us into a better position with rendering. I don't know, right? It could happen. Don't quote me on it either way. But that said, thank you for joining me for another hour of coding with Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, you can pre-order the game on handmadehero.org. It comes with the source code, and then you can download it every night. Get a little link that allows you to download it every night and follow along, which is kind of cool. If you want to play around with the stuff we've been doing on your own, I highly recommend it. We also have, F5 that. There we go. We also have forums. I changed it from news and forums to forums because really there's no news. It's just forums. So we have a forum site you can check out, ask questions on, look at basically community ports to Mac and Linux. There's an annotated episode guide. It's a good thing. When we get the annotated episode guide up a little bit, get it upping more automatically. Maybe I'll put the link here instead of the YouTube archive as well. But point being, there's also a schedule bot that tweets the schedule at you, which is good to keep up with if you want to know when it is. Again, I think it's going to be 5 p.m. Next week at the same time as this week. But just in case, that tweet bot helps you keep up to date with the schedule if you want to know when the thing's going to air. That's all it does is sit there and tweet the schedule. And also, there's the Patreon. If you want to support the video series, you can always subscribe to that. It's much appreciated. But again, the video series is always going to be free. So that's strictly if you're just doing a nice thing. Like I said, you don't have to pay for it or anything like that. It's all the videos are always free. So anyway, thank you very much for joining us, and I hope to see you next week. And yeah, I don't know, maybe we'll do rendering stuff. We'll see what happens. And if you do want to give feedback on the new time slot, please do so on the forums. I read them. I read everything on the forums. I don't always reply to stuff. I'm busy a lot of times, but I always look, and if there's something that I can help out with, I try to jump in. So anyway, thanks very much, and I hope to see you next week. Take it easy, everyone, and have a good weekend.